Java is an amazing language, better than Rust. Disclaimer. Let me preface this by saying my favorite language is Haskell and that I write toy languages for fun. I am a PL nerd, so my opinion is valid. Also, the title is like 20% bait. Jesus wrote this article. It's from 001. I do like that by saying I am a PL nerd, my opinion is valid. I mean, really? Okay, so just to kind of set the scene before we go into this article, I'm going to tell you a little bit of background about myself. I started off by doing Java. Java 1.5 is where I got my education, and this is actually how I became a software engineer, was via Java. I learned how to do some basic game programming in Java. I used to build applets for the web that could drive around little things, and that's how I learned my physics homework, was by applying physics to a little JavaScript or Java application that I made. Yes, Java, not JavaScript, Java application that I made way back in the day. I did not quite understand Java, but I still did it, and I was pretty good at it, and that's how I did it. And so there you go. That's my life. And so Java always holds this warm spot in my heart. Now, as far as Rust goes, is that Rust was my first introduction to a Hindley-Milner system. And when I did it, I thought, man, this is so good. I absolutely love it. And I did Rust so hardcore for multiple years. And then I realized that I don't really like Rust that as much as I thought I did. I really like the type system, but I also realized that structural typing is really nice too. It's just super easy. So you're saying you're Java biased or Rust biased? I think I'm neither biased. I don't think I really like Java, but Java holds like a nice place in my heart just because I have like fond, nostalgic viewpoints, but I remember how much classes and all the boilerplate I had to do. And then Rust doesn't hold nearly as fond of a place in my heart. It's not as fond, if that makes sense. My secret was always that I liked coding in Java in some sort of masochistic way. Everything is dead simple. Everything is so verbose you can never forget what anything is. It is like sitting down and playing a relaxing card game of Stardew Valley. It flows so easily. The feeling of mastery is so easy to attain. This is actually a really great observation, sort of. The one thing that makes Java hard is that you can abstract via inheritance. And often when you get just enough abstraction of IOC plus inheritance, like just enough, right? Like when you hit that real, like when you hit like Chad level clean coding, where everything has like multiple levels of inheritance followed by multiple levels of inversion of control all at the same time, it's a genuine mess. I've done it. It's a mess. Yes, it is a mess. It's genuinely a mess. And so when you mix those two things together, it just gets so difficult. And I've been there. So can I agree with this? Yes. It's very easy to understand what is happening in the thing you're looking at, but its own levels of abstraction can make it also very, very difficult. Coding in Rust is like playing chess and League at the same time. Okay, I already love this article. This article, the fact that we just compared Stardew Valley for Java and chess and League at the same time, this is so good. It is the same mental exertion and the same insufferable people yelling at you on the internet. Oh my gosh. Oh my. The man is stuck in bronze hell, is what I'm hearing. Rust is being stuck in bronze hell in League. The semantics are cool. I love how it borrows stuff from functional languages, but can I tell you a secret? Java gets 75% of the way there with 10% the complexity. Rust is ELO hell. Rust is ELO hell. Okay. Error handling is definitely better in Rust. Absolutely. It's definitely better than Rust. But it is closer than most think. The way errors get buried and propagated up the call stack can be confusing. In complex programs, it can be missed. This is true. I mean, one thing that people forget about error handling and Rust is that everybody just goes like this. Like they just hit question marks everywhere because it's so dirt simple, right? It's just like, that's your problem. You handle it. And then you do that through your entire application. And what ends up happening? Oh, for those that don't, okay, we got a lot of question marks. What the hell is these question marks? So in Rust, a question mark simply means it's the same thing as doing this. Try whatever your statements are, catch with E, return E, right? It's like the same thing. That's what a question mark effectively does, is it's like catching your error at this point and then returning the error back out. So it's like, it's like a very small way. It's returning it's returning at one level. Yeah, Zig has the same thing with try, right? Zig has the exact same thing. This is not a critique of just Rust alone. This is also a critique as errors as values, generally speaking. And so what ends up happening is that you have a program that's 16 lines deep, and 15 of those 16 lines go like this: question, 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 and then you top line one up in main, handles an error that's like a JSON decoding error. And you're just like, and you have to like go all the way through your program and try to figure out how to properly do the thing you're supposed to do. And I've seen this a lot. I've seen this a decent amount of times, and I myself have programmed this a decent amount of times. And so that's the downfall of errors as values for anyone that's wondering. But once you've gone through that, you typically write errors as values a bit better, and you try to handle them as quickly as possible, as opposed to just simply the convenience of the question mark operator. That's why I've never had problem with Go's if error equals nil, is because as I've handled errors long enough, what I realize is that you can't handle most errors with just a simple question mark or a simple try. You actually need to have there's like a lot you have to do. You have to really think about this whole process. Pattern matching is better in Rust, but it is closer than most think. Java records, Java switch statements, optional streams, they're all basically a makeup for the OOP-ness of the language, and are all plenty straightforward. All the concurrent data structures in Java are much nicer to use than Rust. Okay, that's a fact of life. Java's concurrent hash map is the greatest thing that has ever existed. Fight me on that one. Fight me on that one. JavaScript concurrent hash map is so good. And concurrent list is so good. Hash map, good structure, no fight. Why? Never used it. Oh my gosh. It is like the de facto standard. Concurrent hash map is how we made our livelihood. Concurrent hash map is one of the best ever. Cube, thank you for that tier 3. You never even had to do that, baby. Come on, Cube. You're getting into a YouTube video for that one. Thank you very much. Learning Rust is hard. It could not be the language APCS is taught in. The first skill gap is the borrow checker, then lifetimes, then async, then macros, and then you put async plus lifetimes together, and then it just explodiates. Then throw in some traits in there. Then you get these impl traits, but then you have lifetimes in your and then just right. The smallest first skill gap, the borrow checker, was about 10 times harder than learning about Java classes for the first time. About 3.5 harder than grokking monads. I don't know if that's true. I'd have to think about that. I don't know. I spent 2 hours. The problem is that one reason why I have a hard time with that statement in general is that you can't A/B test that statement, meaning that I learned Java and classes were hard to learn. Recursion was hard to learn. There was a lot of things that were hard to learn when I first learned how to program. Then I spent effectively 15 years programming. Then I tried to learn Rust. Was Rust hard or easy to learn? I didn't think Rust was all that bad to learn. Like, if you don't read anything and you just try to use Rust, it's actually really difficult. If you read the Rust book for about 2 hours and you have some level of programming experience, you'll realize that just single-threaded Rust with no lifetimes, with just clone, right, is actually incredibly simple. Like, it is actually incredibly simple. It's not hard because the borrow checker in its basicness is really, really, really simple. I refuse to believe people actually have issues with the borrow checker. You lost me at read? Yeah, okay, that's fair. That's fair. The problem with the borrow checker is that the code is not movable. It is not clear from the code that something has been moved out. No, it is very, very clear. That just means you don't know what's happening with Rust. I think that the code is very, very simple to see if something is moved or not moved. Circular references are still hard. Circular references are virtually impossible. You have to use like this double... You have to do this like whole double index data structure thing, and it's not simple. That's where Rust breaks down, is once you have to do anything that's useful, Rust really gets hard. Are lifetimes part of the borrow checker? If so, the borrow checker is hard. Well, no. I mean, yes, no. Yes, no. You're absolutely right. Are lifetimes part of the borrow checker? If so, the borrow checker is hard. Yes. Lifetimes are hard due to the borrow checker. That's what I would say. That's part of the borrow checker's requirement, yes. Tree and Rust took me forever, yes. That's exactly it, is that once you leave the realm of just like if you build a CLI application in Rust that all it does is read some input, look up some files, parse out those files, and then do something with them, maybe do some JSON and all that, it's actually an incredibly nice language. But the moment you have to do something that's longer lived, lifetimes, maybe produce your own macros, all that, it becomes a very difficult language. It's about understanding the consequences that arise. Simple behavior can lead to complex behavior. Yeah, fair and factual. I can still barely write complex async Rust, and if I see or have to write a macro that is like that's like a hair above the simplest examples, I quit the editor. Honestly, this is such fair critiquing. I think that this is really fair critiquing, which is that writing really complex async stuff is very, very hard, and often you need to use macros. Like, when you go, like when people say, oh, using Rust for a web app is simple, you're like, yeah, you're right. Because all I do is I go there and I use like Axum. I use Axum. I look at Axum, and Axum looks really, really easy to use, right? It's just like, you just go in here. I have a little main statement. I have like a little hello world, and it's like bada bing, bada boom. It's that simple. But what goes into making this work is mind-bending. It is like absolutely mind-bending. And yes, they're even cheating right here, sort of, right? They've made it very, very simple. But I'm just saying that when someone says it is simple, it's not that good. Okay, so right now their arguments are the following. That Rust has a lot of mental overhead, which I don't actually disagree with. I think Rust has a lot of mental overhead, but I think the thing is that there's two different types of mental overhead. Java has a different type of mental overhead than Rust. Java. So Java's mental overhead is proportional to the amount of abstraction. So as abstraction goes up, overhead goes up, right? So it's like that. Maybe it's even nonlinear. I have no idea. Maybe it's logarithmic or just like really small exponential. I don't know. It's hard to say. Whereas with Rust, it's more like features is what makes it confusing. If you use just simple single-threaded clone Rust, it's easy. If you use single-threaded lifetimes, it's not all that bad. If you use async clone, it's not all that bad. If you use async, clone lifetime, things start to get difficult. If you use async clone lifetime traits, right? Like each one, it's like this is actually pretty simple. This is, it's a little hard, but you get it. This is about, this can get a little bit harder. Ouch. And then it's just like, it never actually reaches this point, right? And then we haven't even got to macros, right? We haven't got to the final boss of macros, right? And when you get to macros, you're actually like swirling in on yourself. You're tearing your ACL at that point. And notice that I drew absolutely no dicks. It's crazy. But 8 equals D. All right, I would say that I'd say the most clusterfucked abstract class inheritance system designed in Java would not even approach the most complex Rust design system. I don't think he's wrong on that one. I'm actually having a hard time trying to like argue against it. Like the thing is that to be completely fair, a bunch of abstract inheritance system design in Java makes me unhappy in a deep part of my soul, right? Both are true mess, yes. It makes me 20%, it makes me, not 20%, sorry, I just read this, the 20% bait. It actually just makes me deeply unhappy in my soul. And really complex Rust is more just I get frustrated than I do get like deeply unhappy. So I'm not sure which one I'd rather work in. The problem I see about Rust is the moment you change, say, one lifetime, you have an entire application you have to refactor. And that's a real problem when it comes to these complex, larger applications. Like you want to add a single reference to a string, a stir, like there goes all refactor, baby. It's refactor time. It's uncomfortable, but not hard. I would argue that it's hard. Rust is genuinely hard when you get to a real point. At some real point, it goes from like I said, this is why I said like single-threaded clone and single-threaded lifetimes, they're really like not all that hard. Like, yeah, you have to learn about lifetimes. It's like, it's not that big of a deal. There's some things that could make it hard. There's definitely like a small step function maybe in here, but it's like, okay, it's still in the order of simple, I would say. Simple, but takes time. But once you kind of start applying the other things such as macros or traits and lifetimes and async and all that stuff, it's like the step function just becomes increasingly larger, right? And it becomes super, super difficult to really reason about. Whereas the Java way, it's a runtime mess, right? These are different. This is a compile time mess. This is a runtime mess. And maybe that's like a personality difference. But a runtime mess, the nice part about a runtime mess is you only need to understand a very small portion and you can kind of unfuck a runtime mess. But when you get into the compile time mess, you can't really unfuck it because that's what performance requires. You can't unperformance that. If you've seen performance-based Rust, it is really, really hard. It's really, really hard. It makes you handle your concurrency up front rather than having everything as written, which is nice. Yeah, fair. I'd say fair. It makes you at least it makes you all possible issues are up front and in your face. Yes. 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 I'm not dumb that Java definitely has some complex aspects to it. I also hate the skill issue argument. Like, how you know what the ultimate skill issue is. You not knowing C well enough to make memory safe code. Forget C. You're not going to complete Roller Coaster Tycoon and writing some plain x86 assembly. Absolutely right. Like, I mean, it is true. The skill issue argument does get a little bit annoying in the upper bounds. I think that there's a lot to that is absolutely correct, that the upper bounds argument no longer becomes issues of just skill. It's like experts arguing who is the most expert. And Roller Coaster Tycoon is a great example. Like, there's somebody that could write Roller Coaster Tycoon in assembly, and you're not that person. You're just not. You're not that person. How old is this article? My guess is that this article is 6 months old. The whole point of the language is to be easy. Basically, the Go philosophy, which I do like more than Java these days, although it does not have functional stuff I want. Go's functional nature is not all that great. You can definitely use it, but it's not as nice as Rust. But they do have ranges now. You can range over objects, and I think it's probably right, but the abstraction level of the range in 1.22 is just really ugly, and it doesn't feel very Go, and reading it is just super difficult because it requires a function that returns a function that takes in a function. So you got a function. I'm a function playing a function disguised as another function, right? It's very difficult. Like, the whole point of high-level languages is to never encounter such skill issues. It is to write working code as fast and in a maintainable way. Naturally, you would want this to be easy. This is where Java gets it right and Rust gets it wrong. And what I mean by that is that Java has always tried to be one thing pretty much. It's an application language. It's an applang. It tries to be an applang. That's all it's trying to be. Go got this wrong to begin with because Go tried to be a systems-level programming language to begin with. It's not a system-level programming language. It's not. It's like a networking web programming language where it's actually really good at, right? It's like it's actually really good at that. Java got it right away. Rust did not get it right away. Like, Rust did not get it right because Rust, unfortunately, goes, we're a system programming language. Okay, this is true. This is good. I would agree with this. We're also an application language. Maybe. We're also a tool language. Okay, we're all the things language. And this is where Rust really fails. I think Rust wins. Rust starts losing. Generally, where I think tools can be also in here as well. I think you are right that someone says Rust is great for tools. Depends on the tools, but potentially. I think you're right. Understated take on Rust. I think just Rust got it wrong, and I don't think Rust itself got it wrong. I think the community got it wrong. Because once you touch those Hindley-Milner types, oh my gosh, I do agree. Hindley-Milner types are so good. Oh my gosh. I want them for everything. And oh man, if you can just use macros, you can really make it useful for everything. Like, for everything, right? And that's what's so hard. That's the problem, is Rust can be good for everything. OCaml, unfortunately, functional programming will never take off in the mainstream. At least I don't think functional programming will ever take off. And it's sad. It really is sad. Because I think functional programming could be really cool, and everyone that does functional programming really actually likes functional programming. I just don't think it's going to take off. I just don't. And now, here are some cheap, easy arguments. More people know Java, and more jobs need Java. Tooling is better for Java, and the ecosystem is more developed. Okay, so I actually think that this statement right here is just fundamentally incorrect. I do not think that the tooling, Java versus Rust tooling is just not the same, right? Truly a miss on this one. This actually was a really great argument. In fact, I would say that this was a perfect argument against Rust up until this part. Skipped one. This one is just a goof. Oh, I skipped one? Okay. All right, let me hear. Hold on. Let me read this. Sorry, I skipped one. It is so easy to write good Java with a few guidelines. Duplicate 1 to 2x before abstraction. No inheritance unless you are sure, which, by the way, that means you should just never do inheritance, especially no more than one layer deep. Good advice. Use optional over no. Absolutely. Do not get cute with your abstractions. Java is so easy, people feel the need to make it hard, doing OOP gymnastics to build an elegant systems. Yeah, I mean, the exact same thing's true with JavaScript too, right? So that critique, I think, is a great critique in the sense that you can make identical arguments in pretty much every language that's simple. Because one of the JavaScript's biggest downfalls is the fact that you can curry into a class, you can generate a class from a you've seen this, right? You've seen where people generate just the craziest code, and it all has to do with the fact that you can do it in JavaScript. And the same thing with Java. You can go pretty deep with Java even though you shouldn't. I love curring. Curring is great, but curring is also the devil. Curring is absolutely great during writing, absolutely awful for debugging, because discovering where some of your things got curried at can be such a nightmare. Like, curring is great to write, though. Curring is great. We can all agree curring is just absolutely fantastic, right? Now some cheap, easy arguments. Let's see, hold on. More people know Java and more jobs need Java. This is a great argument. Tooling is better for Java and the ecosystem is more developed. Ecosystem may be more developed, fair. Tooling, not there. The fact that I don't know how to set up my Vim instance to be able to run Java is example. We don't know. It's just awful. Honestly, it's just awful. I absolutely love JetBrains' idea. JetBrains is also fantastic. And no amount of loser Lua NeoVim. Don't come after me. I use NeoVim for C, Zig, and other low-level languages. Config for Rust will match IDE support. Let's see. Okay. Also, if the Prime is reading this, Lua sucks. Don't at me. It is never enjoyable to write. Imagine liking the language I used to code Roblox hacks when I was 9 years old. What is this? Who did this to me? Who did this to me? Who actually did this to me? This is so much BS. First off, Lua is not a bad language, okay? Okay. Don't even try that with me. It's hard to create a mess with Lua like you can in JavaScript, okay? So as far as an embeddable dynamic language, Lua is fantastic. And I do agree, okay? I agree that you can never, NeoVim will never be as great as IDEA, okay? IDEA is JetBrains is a multi-bajillion dollar company that has, 100 to 200 developers working on it full time? But I will say, I'm going to say something that's actually really impressive. I did get my name spelled right. Let's go. Let's go. Let's go. Oh, yeah, baby. Oh, I feel so good. I feel so good right now. I'm no longer in shambles. I'm back in, okay? We're back in. I'm going to admit, maybe I just don't know Rust enough. I think if you think the tooling is better, I think what I read here is that he's mistaking the word tooling for idea. And I do agree. JetBrains is great. JetBrains is unimaginably a great IDE. If I were to not use NeoVim, I would use JetBrains. Okay, absolutely. I typically am in the NeoVim is greater than IntelliJ, which is greater than VS Code kind of camp. That's typically where I'm at. If I had the right, yes, Cargo is greater than Gradle, hands down, unironically, fully, absolutely. If I had to use something for Zig, I would likely choose NeoVim as I am now. If I had to do something for Rust, I'd probably just choose NeoVim. If I had to debug a 2 million line project when it comes to Rust, I would probably choose IntelliJ and try to debug that, because at least I'd get really great support for debugging. Right? Why don't you use JetBrains then? Because I generally don't have any, I don't have any reason to use JetBrains, right? You can use Kotlin as Gradle replacement now. Oh, okay. That still doesn't sound great to me. Okay, if I'm going to admit it, maybe I just don't know Rust enough, but I promise I have coded more Rust than most of you have, and I probably know it better than the average self-proclaimed Rust enthusiast. And yet, if I had to write a big grug business logic project, you would see me reaching for Java before Rust. I'm having a hard time with this one. I don't know. I don't know if I'd choose Java. Like, I really don't think I could choose Java ethically, okay? Because you know what? It doesn't matter that, sure, Java's learning curve is like that, okay? Sure, it's easier. Rust learning curve is like, that. Okay, I get it. You would never do that. But could I ethically choose Java? Right? Could I inflict the pain of Java for years to come on somebody? Or should I inflict the pain of blue hair and lifetimes on somebody? Okay, which one do I choose? If I had to choose, it's a hard choice, but I feel like I'd have to choose the blue hair and lifetimes over the Java, okay? The correct answer is to use Go. Well, that's not the option. We don't have the option here, okay? We don't have the option. Getting paid for easy stuff is what Java is. Java stuff, yeah. Elixir, please. I've never done Elixir, so I can't actually say that Elixir is great. I know Ryan Winchester's in shambles right now. The final thing about Rust that is not even particularly elegant. Haskell is nice to look at. Really? Isn't there like a shit ton of symbols in Haskell? APL, BQN, UI, UA is nice to look at. When I want to puzzle, I write in those languages because I admire the mathematical abstraction. Rust is marred with the compiler, marred with low-level BS that makes it ugly. That does not make it satisfying in this way. If you love language design or the beauty in programming languages, Rust is not even good at that. It's not beautiful. It is not as useful as people proclaim, and it occupies such a small use case that the language is mid. I don't find Rust ugly. Even when I do systems programming, like low-level stuff, I want to manage my own, I just want to manage my own memory. I do not want to beg the compiler to let me write code. I just want to allocate stuff and put it into there. C is fine for this. I'll try Zig later. I think Zig is actually an absolutely fantastic systems-level language. Again, I've been saying this for a little bit. Now that I've actually used it a little bit, I will say that the one thing that's amazing about Zig is that it has null protection, which is good. But you can interrupt really easily with C code, and then you can say, hey, this thing can be null. Like, you just have all these ways to make things nice, and it's simple. But I will say that Zig fundamentally I think Zig is more ugly overall than Rust. I just don't think Zig is that pretty of a language. I find it, like, there's things I hate. Zig is fine. It's not ugly. There's things that I just hate about it, right? Like, I hate the fact, I know this is such a trivial thing to hate, but I hate the fact that I have to surround my Boolean logic with parentheses. I know. Hey, we're talking about ugly. Beauty is in the eye of the beholder here, okay? This is eye of the beholder, okay? You can't judge me. Don't judge me. I love that. Give me all the parentheses. I can. I would say that this is fantastic. Being able to do slices, treating C pointers or like C arrays with a length is just beautiful. And then being able to, instead of doing pointer arithmetic, slicing into it to let it do the own pointer arithmetic, beautiful. Like, I do think that is beautiful. I think capture groups are interesting, right? So for those that don't know what capture groups are, this right here is a nullable, meaning that this thing could be null. It might be null. You don't know if it's null. And so if you do this, you then have to capture it. And capture, like, I like the concept of capture groups. Yeah, I know, I'm on your team. Capture groups are great, IPNAs, but I don't know if I like the looks of them, right? Again, this is me. I'm just saying, this is me. This is beauty, okay? This is beauty. Just let me have my own beauty here, okay? Anything else that I don't like about it? I don't know if there's anything else that I really don't like about it. I think everything else is pretty much just fine. I don't like the fact that if you go like this, like, you can't, like, you have to use a constant, or you have to use a variable, or you have to explicitly assign it to the underscore. Like, sometimes I just want to, like, underscore a variable because I know I'm going to use it in a little bit. Like, I find that just annoying. I find that the fact that they treat warnings as errors can be sometimes frustrating. You know what I mean? I'm not saying Rust is always bad. It has a small but limited number of use cases. Again, I think systems level, if you're worried about that, but I think Zig is winning in the systems department, and I think tools. And I'd be surprised if Go doesn't win in the tool department. But maybe I could be proved wrong. I'm glad to be proved wrong. It's just all comes down to convenience and how large you can make a project. Because the problem is that a lot of us are arguing whether or not Rust is good or bad, or these things are good and bad, and it goes down to us making judgments about languages that are made in a project of 2,000 lines or less. Like, right now I'm at 4,000 lines of Zig, and I'm starting to say, okay, this is what I'm seeing about Zig, and I like the way it scales, right? In cloud, Rust is good for faster than Go. Yes, but the thing is that you're not writing faster than Go Rust. Like, I hate to tell you this, you're not doing it. You're not doing it well. You're not going to do it well, right? Yes, Rust is good for code predictability and safety. This is much more reasonable of an argument, right? You're not that guy, pal. You're not that guy. Like, I hate to tell you this, but you just did an arc mutex on a hash map, okay? You're not the guy. You're arc mutexing your hash map. Sorry, bud. Sorry. For example, I wrote a bot that helped buy things rather quickly in 2020 to 2021, provided I was awake to do the sum of the captchas. I needed it to be performant, robust, and the scope. Wait, hold on. Is he admitting? Hold on. Are we admitting to buying graphics cards faster than everybody else? Is he admitting to being a scalper? Are we admitting to scalping? Scalper admitted here? Boo this man! Okay, police, get the police on here. Okay, maybe he's not talking about that. Maybe he's not buying that. Let's just pretend that whatever's going on, he's actually just buying anime waifu pillows, okay? He could just be a crypto miner. He's just buying anime waifu pillows, okay? Provided I was awake to do some of the captchas. I needed it to be performant, robust, and the scope was just simple enough, even though it was async, where I knew I would not need a lot of code, but a mediocre amount. It occupied the space just before the complexity curve went asymptotic. The other use case is for writing toy languages. It does super well. And its best, at its best, it feels like using a CNC mill to machine a precise gear. Like, sorry, I don't touch grass. Honestly, I don't even know what that means. Like, I don't know what that means, honestly. Both times you need an injection mold and some plastic. But most times you need an injection. Yep, again, it's hard for me to understand this, but yeah, shop lingo, not getting me. P.S. Check out FizzBuzz implementation I did in Java. I have not found a similar solution in Java anywhere on the internet. It shows the power of modern Java. It's actually shockingly rusty, right? Except for you can't do a range. I'd love to see a range instead of an integer. Yeah, so this is just stream this thing, map to object, entry set, stream. I'm not sure what these must be like your, what's it called? I don't know what a predicate integer is, but I assume it just means that if these two things equal, then yeah. I mean, this just seems, again, this is kind of like that whole Java thing. You know how Java is just so effing confusing? Yeah, it takes an int and returns a bool. Yeah, that makes sense. Okay, it takes an int and it returns a bool. But still, like, this is just so very Java-like. You have to know all the Java things to really get this. This makes sense, right? Filter, you have an entry, you get the key, you test the X coming into it. You're closing over the X right here, right? You map the get value. You reduce a string concat, or else one of these values of X. Okay, I think I see what's happening. This makes sense. So you take all of your predicates, which is going to be this. You're going to filter over all of them, which is going to produce a set of 0 or more. You're then going to map over those and get the value out of the entry, meaning you're going to get fizz or buzz. You're going to concat all those strings, so it makes literally like fizz buzz with no separator. And then if it's empty or there's no, or yeah, the iterator itself is empty, then you'll simply do the string value of X. Then at the end of that, you just join all of those with a space, which, by the way, it should be a new line. Okay, if we're fizz buzzing correctly, it should be a new line. Procedural is just so much easier and faster. Generally speaking, yeah, I agree. I agree with that. I think that there's a lot of mental overhead here. I think this actually highlights one of the points that I've disliked generally about a lot of modern programming, is that I'm not sure if this is actually any easier than procedural. I don't think this is any easier to read. Like, I think it's really easy to mutate. I think that if you wanted to add another monadic operation on top of your sweet map, right? These are monads, right? Do I even understand monads? That you're able to abstract and like add in, say, you could add one to it. You could do something very easy to it. Agreed. But I find that it's also just really, there's a lot of thought that you have to think. You have to walk through each step just more, right? It looks like the builder pattern. I'm a newbie. It looks like the builder pattern. Yeah, that's a good way to think of it. It's kind of like a builder pattern. In a sense, one could argue that iterator operations is kind of like a builder pattern. Why do we use classes for interview coding? I don't know. Or a builder pattern of functions. It's just a good way to think about it. Function calls are expensive. We just don't care anymore because modern CPUs are fast. That's fair. I mean, generally speaking, you should not be caring about your function, about the amount of function calls you're making. Generally speaking, that's just probably not going to be your level of programming. Now, there is some people who are doing real programming that actually have to be concerned about function calls. I've been there once by accident. When I was doing a supercomputer research project, I found that one of my getters was slowing down the supercomputer's ability to execute like 100x. Because I had this getter everywhere, and it was old Java before they optimized getters. So the optimized getter was not being executed, and it would actually do a function call to get out a value. And it was doing that constant time, like all the time. And it was littered throughout the program. And so when you're making literally 1,000 extra function calls on every iteration, you're making trillions of iterations, it makes a huge difference. So I literally just made it public, instantaneous, like 100x speed up. And this was, again, Java 1.5. So this is a long time ago, right? This is a long, long time ago. Can Java inline function calls? I'm sure it can at this point. That's like a classic optimization for an interpreted language, and Java in some sense is an interpreted language. Yeah, modern JVM should take care of those cases. Absolutely. Modern JVM does all that. But back then, that was not a thing. I work in scientific computing with HPC. We deal with a lot of this. Good programming and abstraction tend to be very expensive. Yes, it does. It's very, very expensive if you're doing something that requires a lot of execution. But most of us don't do something that's executing super, super fast. Right? Like even my even like my game engine that runs at like what? 15x real-time speed? 100x real-time speed? Some outstanding amount of real-time speed improvement. Even that, I'm doing things I intentionally know are very, very inappropriate. Like one thing that I'm doing that's just absolutely ridiculous is that my game state object, I never deallocate a list item. I just keep adding to the list. And when I do update, I call through the entire list. And if any of them are dead, I just skip it. Like it is intentionally bad. Absolutely intentionally bad. But this thing still runs vastly faster. I do want to improve this. I have an idea. Effectively, what I'm going to do is I'm going to turn this from a tower list, creep list, projectile list, and I want to do just a simple comp time, pool. Turn it into a pool where if two values are, if it's dead, then I will be able to say, okay, this thing is dead. And so I'll have a function call that's expected via comp time called dead. And if it can be called as dead, then it will be called as dead. I think it's a pretty good idea. Did you just describe pooling? I literally just described pooling. Yeah, that's why I said I'm going to do it as a pooling, right? It's just an object pooler built in Zig. And I now feel able to write that code. Whereas if you would have asked me a month ago to write that code, I couldn't do it. Kotlin D's nuts? Absolutely. And by the way, I did see this comments. Where are you? I noticed Prime ignores any of my comments with Kotlin. No, I'm not ignoring your comment. I'm reading your comment and then ignoring it. Because you can Kotlin D's nuts. All right, let's go back to this article. On how's CrowdStrike doing? Oh my gosh, it's going way up. P.S. Please write your applications in Go instead of Java. Otherwise, you might get brainwashed by RxJava. If this happens, no cure can be found. Okay, I like this guy again. This guy's absolutely based. Absolutely based. RxJava is a curse. Rx itself is generally a curse. Go wins over Java. Absolutely, Code Girl. Absolutely. I generally agree with the statement. I think that most things aren't that complicated, and your type system does not need to be as complicated as you think it should be. Real talk, I think most of you don't write complicated enough code. I know you want your code to be complicated enough to need a Hindley-Milner system. It just doesn't. Most of the time, you write really simple code. You have like a buffer, you have some data, you have like 5 objects, you have a couple function calls that go out to a remote server, and you have some sort of database that you're putting stuff into. Right? Like it's really not that complicated. And what I mean by that is that even this thing right here, which actually has an entire system that is designed for like Huffman encoding and testing and doing all this stuff and all of this good stuff, even this, as simple or as much as it is, this stuff is dirt simple to do, and I don't need a fancy type system. I really don't need a fancy type system. And this Huffman is actually doing a byte writer that could write at different byte widths, right? The stride is programmable. And even this is simple to do, right? I think a lot of people overestimate that they need complicated types. But I will say this, that if you're using Go, this could actually be a great short. If you want to defeat Go, all you have to do is create an array of an integer and then a string. Go type system, defeated. You want to defeat Python? All you have to do, create a for loop. You want to defeat JavaScript? Just use React. It's a good one, by the way. Very happy about it. I'm very happy about that. I'm very happy about it. Not funny, dude. It's so correct. Defeating Go with a heterogeneous type list is just like the most awful thing in the universe. Tell me that's not true. By the way, every time I make fun of JavaScript and React, so many people's feelings get hurt. And the reason why is that in short form content, I have a theory that in short form content, the amount of people that watch shorts that are inexperienced versus experienced, it vastly disproportionately goes into inexperienced than it does experienced people. And so when you say something about React, they go, why you make fun of React? And then they get really angry. You know, kind of makes sense. I think it just generally makes sense. What you call an overlap Venn diagram? Yeah, based. Yeah, free real estate. Absolutely free real estate. I'm in here just crushing some good real estate here. But for those that are saying I can just do an interface, an interface array, dude, come on. We all know that sucks. Come on. Can we agree that sucks? Runtime reflection is just super annoying. No, a list of interface, no, that's not life. That's not life. It's not good life. It's not a good life, okay? Isn't that just a vecbox.int? Effectively, that's vecbox.int. Interface is effectively that. Zig does get one thing right about that, is that it does at least do compile time generation of functions, which is pretty cool. Void, oh my gosh, no. No, we will not do, what is this? Do I have this correctly, that this is a function that returns a void pointer that takes in a void pointer? Is this a pointer to a function that takes in a... Am I correct on that? It's a pointer to a function that returns a void pointer that takes in a void pointer. Or an aniopeg, as they call it in Zig. That's how you do it. Aniopeg. I missed the thing. I forgot he typed my name. What's the point? Nobody knows. Void pointer needs to do in a fire. Wait, what? Oh, die in a fire. Void pointers don't need to die in a fire. Void pointers make perfect sense. Like, sometimes you just have memory and you don't know what the hell it is. You're just given a length. A length plus a pointer. Like, what's the problem with that? I don't think that's a problem. I honestly don't think that's a problem. Like, sometimes you don't even need the know, right? Like, you actually don't need to know what's in the memory. Isn't that just a pointer? No. A pointer is just an array, like an address. A fat pointer is a length and an address, right? I like fat pointers. Fat pointers make perfect sense, because then at least you know, not only are you pointed here, but you know how big that thing is. Like, that's great. Avoid double star. Now that on the other hand, that's bad. Your pointer is so fat. Dude, damn, you really think so? Whoa, it wasn't me saying that my pointer was fat, okay? Hey, I received a compliment and I ran with it, okay? I don't think you can come over here and tell me how to live my life, okay? You know why, Karen? Because the name. It's the fat pointer again.